In 1976, the New York State government banned all fishing activities in the upper Hudson River. The main culprit was PCB. Sediments contain high contents of organic matters, which may lead to eutrophication. Heavy metals and POPs affect not only humans, but also the ecosystem. It also causes repercussions on aesthetic functions such as odor emission or color. What about Korea? Is Korea safe? The Korean government made site characterization of sediments at 27 coastal areas. It was shown that the sediments in 21 areas, that is about 78% of surveyed area, more than 8 million cubic meters of sediments were needed to remediation. Thus, suitable remediation technologies are required to clean up contaminated sediments urgently. Conventional soil remediation technologies have been applied for remediating marine sediments. However, it is too difficult to apply those soil remediation technologies to clean up marine sediments because of the high fractions of fine particles, the presence of chlorine ions in marine sediments, and the spatial limits of maritime operation. A new R&D project was started from 2011 to solve the scarcity of remediation technologies supported by Korean government. The result of this project, Remediation Treatment System for Sediments at the Bottom of Water, consists of original modular technology which optimized in marine sediments. The core of modular technology could make optimized remediation at each contaminated site based on separation, movement, connection, and recombination with each module, and overcome any limitation of space. This system could set up in nearshore, marine ship, barge, and land also. This system consists of particle separation, washing, and advanced treatment in a single treatment flow. Treated material could be used for various purposes. Now, look at this system, which consists of 7 modules and have 2 ton per hour capacity. There are various pollutants, such as organic pollutants, heavy metals, TBT, POPs, and contaminated marine sediments. Contaminated sediments put in this system via hopper and conveyor belts. Coarse particles higher than 10 millimeters are separated by wet vibrating screen. Particles lower than 10 millimeters are adjusted with process water as slurry in attrition scrubber. Then, magnetic materials are separated via wet magnetic separator. Two to 10 millimeter particles, second separation range, are also separated by wet vibrating screen. Followed by coarse particles, which are low degree of contamination. First washing treatment using oxidants is conducted in oxidation reactor. OH radicals produced by oxidants treat organic pollutants strong bonded with sediments and various pollutants. Particles higher than 75 micrometers is separated by hydrocyclone, and separated particles lower than 75 micrometers input advanced treatment reactor. In the advanced treatment reactor, nano-sized fine bubbles with OH radicals could treat various pollutants bonded with fine particles strongly. Some part of heavy metals, such as copper, zinc, and cadmium and POPs, could be simultaneously removed with organic pollutants. Then, treated fine particles are separated at 20 micrometers by modular hydrocyclone. Let's look at a modularized remediation treatment system for technology verification. Lower than 2 millimeter particles are treated at oxidation reactor. 75 micrometers of first particle separation by hydrocyclone. advanced treatment reactor, and 20 micrometers of second particle separation by hydrocyclones sequentially. The removal efficiency of organic pollutants was around 80% in each remediation process. Some part of heavy metals and POPs could be also treated simultaneously. Treated sediments could be beneficially used in various products, or placement of treated sediments could be also possible at the bottom of water. The Kushido port in Hokkaido, Japan, for example, used dredge materials as landfill materials, thereby reducing the harbor construction costs. There have been numerous research outcomes from this project. It could be successfully applied in new overseas environmental markets. Consequently, value-add creating of sediments would be now possible. Therefore, the prospect of a substantial market is right ahead.
수저 오염 퇴적물 정화 처리 시스템은 퇴적물의 모든 입자에 대해서 유효 활용을 목적으로 하는 정화 기술이 되겠습니다. 이 기술은 하나의 흐름 속에서 세척과 입자 분리를 기초로 각 공정을 통합해서 모듈화한 것이 특징입니다. 이 기술은 다양한 현장 여건에 적합하도록 공간의 제약이나 처리 용량의 제약 없이 적용할 수 있는 기술이 되겠습니다. 그래서 해양오염 퇴적물 정화 부분뿐만 아니라 육상의 오염 토양 정화나 관련 환경 시장에서 충분히 적용될 것으로 기대되고 있습니다.
The remediation treatment system for sediments at the bottom of water saves humans, oceans, and nature. This original technology is changing our future. KIOST will keep our oceans clean and safe.